In this example, we're going to take the area bounded by y equals x squared. That's my parabola. X equals 0. X equals 0 is just my y-axis. I'm going to go ahead and draw a line there. And then y equals 4. That line goes right through my y-axis at 4, but it really lines up with my area here. So I'm going to go ahead and take this region and revolve it around the x-axis. So I'm going to start by just drawing this, and I'm going to come up with kind of a mirror image-ish of what this looks like. So there's my mirror image. I can even shade in this area here so you get a little bit of an idea. And then it's circular. So I'm going to go ahead and give it a circular top and a circular bottom. Now it's a little hard to imagine, but notice how the outer edges there are straight. So it's actually a lot like a toilet paper roll, but the difference is that on the inside, instead of just being cylindrical, we've got these sloping walls on the inside. Okay, so how do we want to think about this? Now I'm going to go ahead and slice this one again. All of my slices are going to be circles, which is great. But in this case, each of those circles, I can go ahead and draw this outer circle just like a disc, but it's got an open space on the inside. So if I pull this off, my washer looks like this. I've got that open center. And of course, I've got some thickness as well. So I can go ahead and put my thickness in this direction. So in this washer, I've got an outer radius. So if I measure from the center up, I've got an outer radius, and I also have an inner radius. That inner radius measures from the center. It's really hard to see just to the inner edge there. That's going to be my inner radius. Now we've got to answer 3 important questions as we're tackling this one. The very first thing is, what is that washer thickness? Well, I've drawn my washer here, and I can see that that thickness is in the x direction. So my thickness is a dx, which puts everything in motion. I want everything in that integral to be in terms of x. I also need to decide, what is my outer radius? Well, everything is in terms of x, so I know that it's going to be in terms of x. If I draw my outer radius, and I'm going to try and not make this too incredibly messy, but if I draw my outer radius, it measures from the axis of revolution up to that line. Remember that that line is y equals 4. It doesn't matter where I am along this solid, that outer radius is going to equal 4. So my outer radius is equal to 4. Next, let's take a look at that inner radius. The inner radius measures from the axis of revolution to that inner wall. So it's going to be measuring up to the inner wall. I'm going to draw a couple of arrows here so you can see. It's actually measuring up to y is equal to x squared. We know that we wanted it in terms of x, so that is going to be that inner radius. So my inner radius is equal to x squared. Let's put this integral together. Now I want to be able to take those discs, and I'm going to take the outer disc and subtract the inner disc to come up with the volume of our washer. Here's what it looks like. The outer disc, this is going to be a pi outer radius squared times our thickness, which is dx. But I want to subtract the volume of my inner disk. Pi, again, I'm doing pi r squared, the area of that circle, but this is my inner radius squared, and then its thickness is dx. I want to add all of these up. So to come up with my volume, I'm going to use this. I'm going to do a pi here. I can factor the pi out, and I can factor out that dx on the end. So I'm going to do, in the parentheses, outer radius squared minus inner radius squared dx. Now I need one more thing, and those are my limits of integration. I am revolving along that x-axis, so those limits of integration also need to be x's. I know that I'm starting at an x of 0, so I get a 0 right there. To figure out what this other x is, you might be able to guess, but the other x comes when My parabola, x squared, runs into that line, y equals 4. So we want x equals 2 as our upper limit. So I get a 2 right there. Let's go ahead and work through all of this and plug in what we know. So our volume is, I'm going to pull that pi on the outside, 0 to 2. My outer radius is 4, and I'm going to square that, minus my inner radius, which is x squared, and I'm going to square that dx. So we get pi, integral from 0 to 2, 4 squared is 16 minus x to the 4th dx, and I'm ready to integrate. So integrating these, the pi still stays on the outside. 16 becomes 16x, and x to the 4th using my power rule, so I get a minus, becomes x to the 5th divided by 5. I'm evaluating this antiderivative from 0 to 2. Let's go ahead and plug those values in. So we get pi, I'll do a square bracket here, I get 16 times 2 minus 2 to the 5th divided by 5 minus, when I put zeros into that antiderivative, I'm just going to end up with zeros. So we end up with pi times 32 minus 2 to the 5th. 2 to the 5th is 32 divided by 5. If I do my math there, this becomes 160 over 5, and I get 128 pi fifths. This next one, we're going to revolve around the y-axis. We're going to take that area that's bounded by y equals x squared. That is my parabola. I'm going to draw that much of it. And y equals the square root of x. I'm just going to draw the square root of x until I hit my other curve. This is the area that I am going to be revolving around the y-axis. So we get a mirror image on the other side of that y-axis, which is going to look something kind of like this, not too bad. And I'm going to draw a circle there on top. So this one looks kind of like a bowl on the outside, but on the inside of the bowl, it's got these curved edges that curve towards the inside of the bowl. We still need to address these 3 questions. Let's start with that washer thickness. So if I were to draw in a sample washer here, it would look kind of like this. Let me pull it off here. So it's going to look like this. Let me give it some thickness. And we can determine pretty quickly that this thickness here is in the y direction. That puts everything into motion. Everything in this integral is going to be in terms of y. Let's move on to that outer radius. So for that outer radius, I need to go from the axis of revolution to my outer edge. That outer edge is y is equal to x squared, but we want that outer radius in terms of y instead. If I take a square root on both of these, I get the square root of y is equal to x. It's going to be my outer radius. So my outer radius is the square root of y. And that inner radius, you may have guessed it, that inner radius, let me see if I can draw it with a yellow pen here, is going to get me to that inside edge. That inside edge there is the square root. So y is equal to the square root of x. If I square both sides, I end up with that inner radius of y squared, y squared. Finally, I need those limits of integration. I know they need to be y values. My lowest y value is right here, and my highest y value is going to line up with that corner right there. Well, that corner is the intersection. So it's the intersection, and it's where my 2 functions meet. So the square root of y is equal to y squared. You can guess this one. You can solve this one. If you do solve this one, squaring both sides, you get y is equal to y to the 4th. So 0 is equal to y to the 4th minus y. 0 equals y cubed minus 1. And that's going to give me 2 solutions for y, either a 0 or a 1, and that's going to be my upper limit of integration. Let's put everything now together into our volume. So my volume is, I'm going to take that pi on the outside, and I'm going from 0 up to 1 is my highest y value. Inside the parentheses, I want my outer radius squared. So this is going to be my outer radius squared. That outer radius is the square root of y. So the square root of y squared minus, this is going to be my inner radius squared. So my inner radius squared, that one is y squared. So y squared all squared dy. At this point, I'm always feeling super good because I know that I just have simplifying and integrating left to go. So this thing gets a lot nicer as we go. I end up with that pi on the outside, 0 to 1. The square root squared, that's just y. And y squared squared is a y to the 4th, and I've got my dy there. Let's do a couple of power rules. So I get pi, y squared divided by 2 is the integral of y, and that antiderivative or integral of y to the 4th is y to the 5th divided by 5. Super nice limits of integration. We're going to evaluate that from 0 to 1. So as I put this in, I get 1 over 2 minus 1 over 5 minus, and putting zeros in just give me zeros. So all I've got left to do is that 1/2 minus 1/5. Using a common denominator, that turns out to be 5/10 minus 2/10. And we get our final answer of 3 pi tenths. You are doing fantastic. Take a look at this next video and keep up the great work.